Good evening, and I welcome you students for important lecture on periodic classification. Students, we are working on periodic classification of elements, and last time I have told you the importance of S block elements, alkali metals, and their physical as well as chemical properties. And we have in our course student another important group 17 elements. Now, what are these group 17 elements, students? You are already aware of them, students. Halogen family, halogens. You know, students, group 17 are called halogens. Halogens. What is the meaning of halogen, student? These are usually Greek. Halo means salt. Salt genes. Salt genes means born, salt born. So salt genes means salt born student. They are salt born because you are aware of them. They are salt producer students. You know, so many salts are known to you like NaCl, you know, sodium chloride. Sodium chloride is aware of you. And therefore, student, these are called salt producers. And these halogens are highly reactive, I am saying. Alkali metals were also highly reactive. Yes or no? Tell me. Alkali metals were highly reactive. They were having very low ionization energy students. They were readily losing electrons and metals. And these are non-metal students. What are these? Non-metallic elements. Non-metallic elements. What do you mean by non-metallic elements, students? Can you tell me what do you mean by non-metallic elements? When I say they are non-metallic, what it means? What it means, student?
Non-metallic elements means they take electrons.
They will gain
They
electron to form
they
X
will gain
minus,
electrons.
highly electronegative. They are highly electronegative students. They have a strong tendency to gain one electron, students. We will see very soon the electronic configuration to find out why they are doing it. Alkali metals were losing an electron, student, readily because they were getting noble gas stable configuration after losing one electron. They will become stable noble gas after gaining one electron, as we will see their electron configuration, students. So students, basically when you see the occurrence, fluorine, chlorine are abundant while bromine, iodine are less so. Fluorine is mainly in insoluble fluoride, student, fluorospar, cryolite. These are the ores, student, ores, minerals in which they are present. CaF2 is called fluorospar. Cryolite is a ore of aluminium, student, sodium, aluminium, and it has F6. Similarly, fluoropatite, student, this has CaF2 and also present in soil and river water, plants and bones and teeth of animals. Seawater contains a lot of chlorides, bromides, iodides of sodium, potassium, magnesium, and calcium. You can see that alkali metals and these group 17 are forming large number of compounds. Why? Can you tell me what is the reason? We are saying sodium, potassium, magnesium, calcium. देखो potassium, potassium, magnesium, calcium. They all belong to student S block. They are metals. They will readily lose electrons. And halogens are fluorine, chlorine, bromine, iodine, astatine. Student, they are readily going to gain an electron. So that is the reason you see a lot of chloride bromides also. And then mainly C contains sodium chloride 2.5% by mass. Student, the deposits of dried up Cs contain these compounds. Sodium chloride, carnallite, student, and marine life contains iodine in their systems. Iodine in their system as seaweed, student. So about 0.5% of iodine and child saltpeter contains up to 0.2% of sodium iodate. These are some of the sources in which these halogens are present. That is why they salt-like. Student salt genes. You have noted everything. Then I proceed further, students. You have noted. Can I proceed further, students?
Can you, pardon, sir?
Can I proceed further or you are noting?
Yes, sir. Yes, sir.
Okay. Now, always we are studying some of the atomic and physical properties. Student, halogens, when I write, student, the elements I am writing, what elements you have, student? Fluorine, chlorine, bromine, iodine, astatine. I am putting a star. Why did I put star, student, on astatine? What is the meaning of that, students? When I put a star, that means it is radioactive. It is a radioactive, student, element. So you know when elements are radioactive, the chemistry we are not studying much about them, and it is not possible to study their chemistry. Only they are there in nuclear reaction, students. So mainly we will be studying fluorine, chlorine, bromine, and iodine, student. And when it comes to atomic number, if I write 9, what is the magic number? I add 8, student, 17. Then magic number 18, student. What will be that? 35. Then add another 18 as magic number, 53. Then add 32. What do you get? 85. These are the way, this is the way we calculate the atomic numbers. We have told you, students, they belong to the fluorine belongs to second period, student. So we are already going from first period is over, second period, fluorine, chlorine, bromine, iodine, astatine. And students, the important question is first one, their electronic configuration, students. Group 17. Which group is this? What group is this, student? Tell me. Group 17 means what, student? 17 minus 10. How much? 7 will be the
7 electrons in the
number of
last shell.
valence electrons, or valence shell electron means outer shell electrons. So number of valence shell electrons is how much? 7. How will you complete 7, student? What it means? Then that means ns2 np5. Is it okay? 2 plus 5 is 7. 2 plus 5 is 7, right? And n is your principal quantum number, which is the period number, student. Period number. N will be the period number. Therefore, student, if I start with fluorine, student, if I start with fluorine, what will be the fluorine is atomic number 9, student. Which period is this? What is the period of fluorine? Second, right? So second period, student, which are orbitals are there? 2s2, 2p5, n equal to 2. That means second period means n equal to 2. The outer shell. Outer shell is second. Then what will be the configuration? 1s2, 2s2, 2p5. Is it clear?
Yes, sir.
This 1s2 is nothing but helium. If I put the noble gas configuration, helium 2s2, 2p5. So you can write helium 2s2, 2p5. Then what is the next one, student? If I take 17cl, what is the period number of Cl? Tell me, student, period number of chlorine. Which period is Cl?
The period of Cl is
3. N equal to 3. Here n is equal to 2. Then what will be the last one? 3s2, 3p5 students, and then 17, then you have to write the inner configuration student. This I could have written like helium and 2s2 2p5 students. That was 2. Here I am saying that neon is 10, then 10 plus 2 12 plus 5 17. Okay, this is how I write the electronic configuration students. Similarly, I go to 35, then 35 BR student. BR belongs to which period, students? Fourth period. Fourth period means what? The last shell will be 4s2 4p5 students, and after helium 2 plus 8 10, 10 plus 8 18. What is that? Argon. How many electrons are there? 18 plus 2 20 25. But there are 35 students. Then what will happen? There will be 3d10 also here. So we can write the electron configurations. And next one, if I have 53 I student, 53 is the atomic number of iodine. This belongs to fifth period. Fifth period means it will be 5s2 5p5 students. Then you have helium, neon, argon, krypton student. What is the atomic number of krypton? 36 plus 2 38 43. Then you have here 4d10. So like this, we can write the electron configuration. Can you tell me any doubt?
No, sir.
So all we have to see the period number here, n is equal to 5. Period number is 5. Period number. Once I know the period number, student, then it becomes easy for me to write the electronic configuration. Always we are writing, first thing we do is to write the electronic configuration. And the important point to note is, students, that these halogens NS2, NP7, if they gain one electron, what will they form? NS2, NP6 student. What will be that? They will go to noble gas stable configuration, right?
Yes, sir.
That is why they have a strong tendency to attract one electron. That is why they are highly electronegative element students. They are highly electronegative elements. Is it clear? ठीक है? Now let us see the second property. Atomic property, second atomic property, atomic and ionic radii students. Tell me, students, when we learned the periodic table, group 17 are the last elements on this side in the P block. What happens across a period? Tell me, atomic radii increase or decrease? Tell me, atomic radii increase or decrease? If you move across a period, student, if you are moving across a period from left to right, what happens to the atomic size? Tell me. They increase or decrease? Fast, 30 seconds. When you move across a period from left to right, student, will the atomic radii increase or decrease? What will happen?
Uh, I'm not sure, sir.
Will the atomic radii increase or decrease if you move from left to right in a period?
In a period, it will increase.
Period, it increases. You have forgotten everything.
The atomic nucleus, right?
Radius, what is that? I am talking of atomic radius.
Okay, it reduces.
It decreases, student, because the effective nuclear charge increases. Therefore, student, Halogens have the smallest atomic radii in the period, student. Smallest atomic radii in respective period, students. The largest one were alkali metals. We told you alkali metals have the largest atomic radius. You move from left to right, student size will become small. So atomic, they have the smallest atomic radii in a period, student. But what will happen down the group? If I move down the group, what will happen to the sizes, student? There will be atomic and ionic radii increase when you move from fluorine to chlorine. Down the group, student, this is the first point. Down the group, what will happen? Atomic and ionic radii will increase, student. Why they will increase? Why they will increase, student? Due to addition of new shells. The number of shells increases, yes or no? Down the group. So size will increase. Size will increase. As the number of quantum shells will increase, the size will keep on increasing, students. Is that clear to you? Tell me. Right?
Yes, sir.
What is the next property we study, student? Ionization enthalpy. What is the ionization enthalpy, student? When how much energy is required to remove an electron from a neutral gaseous atom? Tell me, do they have tendency to lose electron or gain electron?
They have the tendency to lose electron.
They have tendency to lose electron. Halogens lose electrons,
No, 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 they have the tendency to gain electrons.
gain. So we can say that they have very little tendency to lose electron. Therefore, student, their ionization enthalpies are high. Ionization enthalpies are high, students, because they want to gain electron. They don't want to lose an electron, students. And what will happen down the group? Ionization energy will increase or decrease down the group. Tell me fast. If I go
Ionization
down the group,
energy will. Hmm?
ionization enthalpy will increase or decrease. If I move down the group, student, will the ionization enthalpy increase or decrease?
It will decrease
Decrease. Why? We have told you so many times, ionization enthalpy is
because atomic
directly
size
proportional
increases.
to atomic size. Down the group size is increasing. Therefore, ionization enthalpy decreases. The most important property we have discussed this electron gain enthalpy, student. What is electron gain enthalpy, students? What is electron gain enthalpy? Tell me, student, what is electron gain enthalpy? We have told you so many times. When you add an electron, student, to the halogen, what happens? They will release energy, negative energy. More the affinity, more the negative energy released. Yes or no? Tell me. What we are saying, you have Xg halogen, add an electron, you will get X minus G and delta electron gain enthalpy. Student, negative value. More the tendency to attract electron, more will be the negative gain enthalpy. Yes or no? Tell me. Yes or no?
Yes, sir. Yes, sir.
So as you go down the group, this value should decrease because the size is increasing, students. Yes or no? Yes or no? Tell me. So this is what we are expecting, student. These values are always negative because energy is released, student. Here energy will be released. You know about it. Let us see what are the values we have in the table, student. This is the electron gain enthalpy kilojoule per mole. Can you see it? Fluorine minus 3.333 chlorine. Then as you go down, this value is decreasing, 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 decreasing. Can you see it? 349, 325 to. But here what has happened? Increases, increased. Now this is an
Or it
important question.
decreased.
It is an important question here, student. That question will be asked in the paper. This is something important, student. That the electron gain enthalpy of fluorine is less negative than the chlorine. Why, students? Though fluorine is smaller in size, it should be more. But the question, this is an important question. What is the important question? Electron gain enthalpy of fluorine is less negative than chlorine. Explain. Tell me, students, how will you explain this? How will you explain this? Important question for the exam. Tell me, what is your answer, students? You have 30 seconds to answer the question, student. Tell me, what do you know about this? What do you know about this, student? Why the electron gain enthalpy of fluorine is less? Important
Since
question for the
fluorine
exam.
has a smaller size,
Due to very small,
due to due to
compact size
fluorine
of
being smaller size, the
F,
greater electron repulsions.
there, the fluorine has a lone pair of electrons. You know how many? One, seven electrons are there, and one more is
Yeah,
coming. There will be high
repulsions.
electron repulsion.
So fluorine does not accept any more electrons.
No, no, it accepts, but the value is less negative than chlorine. Question, read the question. What I am saying. It is accepting, but the energy released is less than chlorine. Why I didn't say it is not accepting. The value has been given minus 333, minus 349. Less energy is released in this case. But more because size of chlorine is bigger, the electron repulsion becomes less. So more exothermic, more heat is liberated when electron enter the Cl. All are electronegative elements. They all are going to gain one electron. That you know, right? Clear? Got the answer?
Hmm.
These values are given. These are the ionization enthalpy decreasing. Ionic radii, you can see increasing, increasing.
So basically, because fluorine has small and compact size,
Yes.
and it has a lot of electron to
Lord
electron
kya seven, the lone pair, three lone pairs of
repulsion.
electrons are there. I will
So
know
it
the exact number.
so the incoming electron does not experience very much attraction because of that
The incoming
repulsion.
electron is experiencing high repulsion, student. Therefore, the reaction is less exothermic as compared to chlorine. The size of chlorine is bigger than fluorine. Fluorine is small. Chlorine is larger than this. So electron are there here also. Same number of electrons, 7. Here 7. Another electron is coming. This is coming when here more repulsion because the size the electron density is very high. Here the size is bigger, so electron density less, less repulsion. Here more repulsion. That's all I'm saying. Clear? You understood? Any doubt?
No, sir.
Okay. Next we are coming to the electronegativity, students. You already know they are the most electronegative elements. Most electronegative element, students. And what will happen to electronegativity as we go down the group? Tell me, down the group it will increase or decrease? If I move down the group, electronegativity will increase or decrease? Tell me.
Wait,
Will
sir.
the electronegativity increase or decrease down the group, students? What is your answer?
Electronegativity.
As you move down the group, what happens to electronegativity? It increases or decreases down the group?
It decreases.
It will decrease because the size increases, because atomic size increases. More the size, farther away is the electron from the nucleus, attractive force will become less, student. So most electronegative element is fluorine. Which is the most electronegative element? Tell me. Which is the most electronegative element? Fluorine, which is given a value of 4.0 in the Pauling scale. Most electronegativity. You can see electronegativity 4, 3.2, 3.0, 2.7, 2.2. It is decreasing. Pauling devices relative scale, student. Highest value is 4, student. And you can see value is decreasing down the group. So most electronegative element is fluorine. And here are hydration enthalpy, students. You can see hydration enthalpies are always negative, the energy released when these ions are hydrated. So you can see that which has the highest value of hydration enthalpy, fluorine, because of its smallest size. Can you see that it is hydration enthalpies are decreasing, student, due to increase in sizes? Due to
Yes, sir.
increase in sizes. You know, when ions go in the solution, they are hydrated, they are surrounded by water molecules, student, and they interact with them, dipole forces. So what is the result of that? Heat is liberated. But in this case, you can find fluorine is the smallest, therefore charge is very high. Higher the charge density, greater will be the hydration enthalpy. You have noted down everything, then I will proceed further. Clear?
Yes, sir.
Okay. Some of the, let us see some of the physical properties, student. Physical properties of halogens. You know that they are existing as F2, Cl2, Br2, I2. ठीक है? And students, these are colored. They are highly colored. Halogens are colored, students. And you can see at room temperature and pressure, student, F2 is a gas, Cl2 is a gas, Br2, what is bromine? Br2 liquid, and iodine is solid, student. What? At room temperature. Can you see that? Tell me.
Yes, sir.
This is the first question to now. This becomes a question in the paper. Explain why. Why fluorine is gas, chlorine is gas, bromine liquid, iodine solid. Why, student? What? How you can explain this? How can you explain this, student? Such questions are asked in the paper, students. What is your answer?
Um,
What happens as you go down the group? Down the group, students. What is happening?
to the elements.
Down the group, what is happening? The molecular mass is increasing,
Yes, sir.
molar mass increases. What is the result of that? More protons, more electrons. What happens? What are the attractive forces between these molecules, student? They are non-polar. Van der Waals forces. There are Van der Waals, London dispersion, attractive forces, students. And you know, as the molecular mass will increase, size will increase, what will happen? The van der Waals force will increase. And these forces are directly proportional to molar mass. So as you go down the group, molecular mass is increasing, yes or no? Tell me. Molecular mass is increasing, students, down the group. What is the atomic mass of iodine is 127 and fluorine atomic mass is 19. This atomic mass is 19. This is 1. Iodine is 127. Fluorine is 19 atomic mass. It is increasing. So what will happen? Van der Waals force, attractive force will increase. And when force between the molecules will increase, what will happen? They will come closer. That is why fluorine is gas, chlorine is gas, bromine becomes liquid, and iodine, the molecular mass is so high, attractive force becomes stronger, it becomes solid. Students, note it down. Important question. Noted?
Which are writing, sir?
Write down. Next question, student, which is visible from here. What is the next question, student? They are colored, students. Halogens are colored, students. What do you find? All halogens are colored. All halogens are colored, students. Yes or no?
Yes, sir.
What are the colors? Fluorine, pale yellow. Chlorine, yellowish gas, yellow. Bromine, deep red, orange. And iodine, purple violet color. Purple violet color. The question is why they are colored, student? Why halogens are highly colored, students? What is your answer? This second question here. Why the halogens are highly colored, students? Important question for the paper. Why anything is colored? Because they absorb light in the visible region. Electrons are excited,
Yes.
but excited electrons only stay for short period of time in excited state, 10 minus 8 seconds. Or then they fall back and will emit, student, emit the light which is absorbed, and different quanta of radiations are emitted will give different color, students. So here we can say that the color is due to student absorption of radiation in the visible region. Which region? Visible region. And what happens? The electrons are excited. Outer electrons are excited. The outer electrons will be excited to higher energy, student. ठीक है? And when they will come back, student, what will they emit? They will emit, student, radiations of definite wavelengths or definite frequencies in the visible part. And you will see those colors. Clear? 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 Tell me. Is it okay?
Yes, sir.
Important question is there, student. They are colored. Highly colored solution, students. Noted?
Yeah.
Colored due to absorption of radiation in the visible region, which results in excitation of an electron to higher energy, absorbing different quanta of radiation. Therefore, they show highly colored, students. What is happening to their melting point? Question number 3. Melting points. As you go down the group, what is happening, students? Minus 220, 1017. Melting points are increasing, students. Down the group, what is happening to their melting point, students? Tell me. These are the boiling points and melting points, students. Down the group, what is happening? Minus 220, minus 101, minus 7, 114, minus, minus, minus. They are increasing. Increasing,
Yes, sir.
student. Why they are increasing? So as you see, fluorine, chlorine, bromine, iodine, as you go, as the melting points, boiling points are increasing, students, what answer you will give for these students? We already told you with increase in molecular mass, what is happening? The van der Waal attractive forces, van der Waal attractive forces, which are here,
Yes.
London's dispersion forces, student, increases with increase in molecular mass. Therefore, student, you can see the melting points are increasing, increasing, students, down the group. Clear? The melting point iodine is more than Br2, is more than Cl2, is more than F2. Is it clear? Got it? Right? The size you can see increasing. These are negative values, degree
Yes,
Celsius.
sir.
Fluorine, chlorine, bromine, they are increasing. Increasing melting points. Clear? Yes or no?
Yes, sir.
Okay, then this ends the physical and atomic properties of the halogens. I will meet you in my next lecture and we will continue further, students. Whatever topics you have, we will try to revise as many as possible
Okay,
for
sir.
your exam, students. Chemical bonding and this, all that is in your course. We will try to finish it up. Okay, good night. See you next time.
Thank you, sir.